Hello, my name is Duncan Wells, Principal of Westview Sailing, author of the Stress-Free series of sailing books and creator of MOB Lifesavers. And here's a tip. Telling the time by the stars. Is your watch broken? No? Well, pretend that it is. You see, we can tell the time by looking at the stars. You need to be in the northern hemisphere for this and able to see the North Star, or Pole Star, or Polaris as it's called, and you'll get the time in your local time zone. Then you need to allow for daylight saving time where this applies. So we'll take the Plough, the Big Dipper to some. Line up the last two stars in the pan section, Merak and Dubby, and they point to the Pole Star, also called Polaris, or the North Star, and which points to true north. Now make a 24-hour clock face with 24 at the top. Make a hole in the centre. You're probably better off imagining it or perhaps printing it on an acetate so you can hold it up to the night sky and see through it, if there's enough ambient light, or light pollution, should I say. Find the Plough and see where the two pointer stars are pointing to the North Star, and with the North Star at the centre of your imaginary clock, estimate what position the pointer stars are showing on the 24-hour clock face. Here they line up with the 23. Now, before we see what the time is, we need to know where we are in the year. You see, the Plough will be at different positions in the sky throughout the year, although the pointers will always be pointing to the North Star. This is what it looks like at different times of year, whether we're in spring or winter or autumn or summer or whatever. And we reference our time to the 6th of March. It's all to do with the fact that we're zooming round the sun in an elliptical orbit at 67,000 miles an hour in order to get round within a year, while at the same time we're spinning at about 1,000 miles an hour at the equator. Amazing! Where I am, we're doing about 625 miles an hour, and not a hair out of place. And where we are on the ellipse defines the position of the Plough, and where we are in terms of our spinning defines the time. So to calculate the time from our observation, if we're on the 6th of March exactly, or close to it, we can take the time directly from the clock. Here the pointers show 23, so that's 11 p.m. When we're not exactly on the 6th of March, we deduct 2 times the number of months after the 6th of March we are making our observation in, from the time on our clock. Here we are on August the 6th, which is 5 months after March the 6th, and the pointers show 14. So 14 minus 2 times 5, which is 10, leaves 4. That's plus 4, so we're 4 hours after midnight, which is 4 a.m. Here on the 20th of December, which is 9.5 months after the 6th of March, we have the pointers showing us 20. So 20 minus 2 times 9.5, which is 19, leaves 1. And so it's 1 hour after midnight, in other words, 1 a.m. Here on the 10th of January, which is pretty much 10 months after the 6th of March, we get 16.5. So we have 16.5 minus 2 times 10, which is 20, which leaves us with minus 3.5. So 3.5 hours before midnight gives us 8:30 p.m. And finally, to make sure we've got it, on the 20th of February, the pointers give us 2. So 2 minus 2 times 11.5, 20th of February is 11.5 months after the 6th of March, which is 23, leaves us with minus 21. That's 21 hours before midnight, which is 3 a.m. At the 20th of Feb, we're getting close to the 6th of March, which is why the reading from the clock is very close to, within an hour, of our time adjusted for the month. Hours of endless fun. Of course, if it's overcast, you're buggered. Still, you've always got your digital watch. Watch out for more tips soon.